live. Hopefully, we're live, and I'm waiting for YouTube to hear my audio on YouTube. So today, now let's wait for YouTube to start so we see that our audio is good. One, two, three, four, five. Yes, our audio is good. Okay, let's start. So today, I'm going to explain why you should stop saying space time, but rather say space. So let's begin. So, so according to Einstein in his famous thought experiment, so we have two mirrors and a photon bouncing up and down. And when I imagine, let's say it's a thought experiment. So in this thought experiment, we're going to have this clock. It's going to be placed on a cart with wheels. It's a train. It's on a train, and it's moving in this direction with some velocity. And I am an inertial observer, and this train is moving at a constant speed. I'm stationary relative to it. I'm assuming I'm stationary. Let me quiet down my phone. All right. And so according to Einstein, so I'm going to notice that this clock is ticking slower. So when in the beginning, let's say the velocity is zero relative to me, so it's not moving. So let's say it's ticking once per second. So one tick per second in the beginning when its velocity is zero. But as its velocity starts increasing more and more and more, so it's no longer zero, what is going on? So according to Einstein, if we look at the new cart with the new clock, so the photon, in order to bounce up and down, right? So when the train, let's compare two steps or two situations with the train. It was here and then it was there. Let's say it was here a moment ago and it moved to there. So what happened to the photon? So according to Einstein, the photon now has to travel, or had to travel, to some intermediate step, actually. So it had to travel to some intermediate step. It had to travel to here, and then it had to travel to here in order to tick. So the photon needed to travel a greater distance in order for it to tick once. Okay, but Einstein assumes that the speed of light is a constant. That's his assumption. Why did he do it? That's maybe we'll do it in a different video, and the notion of a photon is therefore incorrect, but that's going to be for a different time. So according to Einstein now, given that a photon, for some weird reason, a photon always travels through space, according to an observer, the photon can only travel at a constant rate. So I'm always measuring the photon moving at c, the speed of light, 300 million meters per second. So that's the speed. But since this distance is much greater than this distance, therefore this tick must be slower. So according to Einstein, when something moves through space, it must tick slower. Now, does that mean time is slower? I would say no, this has nothing to do with time. I mean, it has to do with relative clocks. So my clock is simply ticking, according to me, my clock is ticking normal. So my clock is ticking faster than the moving clock. But notice that the photon is still moving at the same rate. So there is no difference. So why do people say something about space time? I would say there's nothing here that has to do with space time. But hmm, that's not a good reason not to say space time. There is no. Let me think. Okay, I'm going to think and come back.